The famous physicist Richard Feynman had once said that in order to calculate and understand a quantum object, one should build a quantum computer. As all natural objects are governed by the laws of quantum physics, we might just say that in order to understand nature or the whole universe, the concept of the quantum computer might help us everywhere. Or is there an exception? Yes, there is, some smart people will answer. There have to be exceptions, because we also have gravity, and thus a quantum computer will not help us there. We would need a quantum gravity computer in order to be on the safe side and really cover it all. Cover it all, we ask. What about humans and their societies? And the smart people will probably think that this question was meant in the sense of, what type of machine should we build in order to understand human societies? The smart people will just smile, and if they are really smart, they will shake their heads, say nothing, and walk away. So we are left with our question. I mean, with our original question, and not with the one everybody thought we asked. However, we are not as dim as those smart people thought we are. We know that they consider our question stupid, because they think we only asked it out of the feeling that human beings and their societies are special and somehow not governed by the laws of nature. But this was neither our way of thinking nor the intention for our question. We know that human beings are governed by the laws of nature, and human societies are governed by the laws of nature. So what we really want to know was, how big do we have to build the quantum gravity computer machine in order to also allow us the simulation and understanding of the working of societies, not necessarily only human ones? So better be prepared. This short video will take you where no man has been before. Let us start with something many people only connect with humans and the invention of computers. Let's talk about information. Probably only very few can imagine this having anything to do with those crazy objects in the universe we know as black holes. But this is exactly where we here want to discuss the deeper nature of information. We want to answer the question how and where black holes store information, and along the way, almost as a byproduct, we are going to see what information is, at least in our universe. This is the thought experiment of Professor Birkenstein from the early 70s of the last century. Professor Birkenstein had the funny idea of feeding a black hole with photons. By carefully choosing the size of the photon always such that it was just as big as the black hole, the only information being connected with the photon either passing the black hole or vanishing into it was a yes or a no, standing for the photon fell into it or it passed the black hole. In this way, Birkenstein actually was feeding the black hole with yes-no information, which means bits. In order to find out what these information are, respectively how they are stored by the black hole, we now only need to know what the photons do with the black hole the moment they fell into it. The answer can be found purely mathematically and simply is: black holes store information bit by bit as dimensions. Thereby, more dimensions mean more information and vice versa. With each added bit, the black hole also grows, and so it grows in dimensions as it grows in size. Smaller black holes have a lower number of dimensions, or inner degrees of freedom, than bigger ones. Please note, as a byproduct we also find the internal structure of black holes and extract the information that they probably do not contain a singularity. But what did this tell us? Well, we saw that something we usually connect as a very human-related thing, like information, sometimes has a very fundamental footing within the ordinary laws of nature. But is it always necessary to dig so deep? Well, sometimes one has to learn it the hard way. Yes, perhaps even due to personal loss, that too shallow knowledge often is no knowledge at all, that not asking for the fundamental origin of everything can lead to disastrous consequences, and that sometimes not asking for the fundamental origin of the things of interest will make you miss the important and/or unexpected. In other words, in not trying to dig as deep as possible, it often makes you miss the best part of it. Our next example will show the connection between socio-economic spacetimes, which is to say the dynamic of societies within their natural habitat, in the fundamental laws of our universe in a much more illustrative manner. We will go back in history to the Battle of Midway, the probably most decisive sea battle in the Pacific in World War II. Don't worry, in order to keep the show entertaining, we assume a few outcomes very different than they really happened, and investigated the consequences. It is well known that the Japan Empire originally intended to use the Battle of Midway as a bait to lure the US fleet into the open in order to destroy it. The result, in a sense, was the other way round, which allowed the US military to win the initiative in the Pacific. But let us now imagine a slightly different outcome, one where not the USA but the Empire would have triumphed. In contrast to many similar investigations analyzing the complex what-ifs, partially in great detail, we here only concentrate on the effect of the socio-economic spacetime of the US society. It is quite amazing how similar all the blows the USA would have to endure after our assumed Midway disaster, for the USA we mean, appear to multidimensional impact scenarios. All the internal and external problems which will occur as an aftermath of Midway will contribute as blows into an already quite stressed society. And this picture also directly leads the way to the math required to simulate the various effects on the US socio-economy, including the extremely important moral parameters. In understanding the working and the dynamic of a society as admittedly complex, multidimensional interactions of individuals, clusters, and groups within a society, we realize that we can obtain a very holistic and complete description of the latter by the notion of displacements, stresses, and strains. And so it is little surprising that, summing up all bad stresses, the overloaded society will show severe failure under multiple attack, just as we see it in the animation here. Thereby the black areas are illustrating the huge areas of total irreversible damage caused by the socio-economic suffering of the losing war. But stop, wait a moment. We recognize the animation. Haven't I just seen it somewhere else? And wasn't it in connection with something completely different? Yes, I remember now. The animation didn't show any socio-economic outcome at all. It illustrated the effect of particle impact on an inner fusion chamber wall. You might feel cheated now because, classically thought, the illustration had nothing to do with the socio-economic problem of a post-Midway disaster. Or, haven't we, just a little while ago, found that all this impact, stress, strain evolution acting on our society quite convincing? Yes, indeed, and we already know why this is, don't we? In principle, namely, we already gave the answer. Let me just recapitulate it for you. In understanding the working and the dynamic of society as admittedly complex multidimensional interaction of individuals, clusters, and groups within a society, we realize that we can obtain a very holistic and complete description of the latter by the notion of displacements, stresses, and strains. So, In socio-economic space-time or fusion chamber wall, in principle, it is the same fundamental mathematical origin. The only problem is to find the right interactions and, what is even more important, consider all of them. Thereby you can never start fundamental enough, and this is exactly the reason why we avoid any man-made suggestions about the inner workings of a society. That is the reason why we rather go for the original, the natural laws and subsequent universal driving forces for evolution, and the self-organization of bionetworks. And that is the reason why we prefer to drive also the human society from scratch. This is the only way to avoid the classical human flaw in building a model, namely by incorporating one's own preferences and wishes into the very model and thereby influencing, partially even already, determining the results. But there is one big disadvantage, of course. We will not be able to tamper with the outcome any longer. We might find ourselves in a position where we have to accept the result of our work, even though we might not like it at all. However, for those being interested in the truth, and only the truth, this probably is just the total opposite of a disadvantage. And now, in closing the circle to the beginning of our short presentation, we state that just as with the fundamental nature of information, being now revealed bit by bit, just as dimensions or degrees of freedom, we shall always start as fundamental as anyhow possible. This most especially holds for everything having to do with socio-economic modeling. And in having established such a deeper connection between the natural laws and our human societies, we might even be able to truly solve certain problems. So, with respect to our midway example, of course, even after a potentially different outcome of the battle, there could still be measures to assure the winning of the war. After all, the strength of a society is not just defined by its military power, but also by the strength of the bonds among its individuals. Taking all uncertainties into account, the three animations here show a fusion chamber wall, but this time the material has been reinforced by protective layers and intrinsic stresses. One might see this as a strengthening of the interaction. This time the material, as we can see, has a much better chance to survive the impacting blows. Now we leave it to the audience to see the connection between the bonds among individual atoms and human individuals of a society. Surely you will be able to use your imagination and come up with the right countermeasures after a potentially lost battle of Midway, simply by using our very fundamental association.